Hello students, I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. In Fourier series, today's topic is Fourier series of even and odd functions. So today I will teach you how to find out the Fourier series of and odd functions along with the basic concepts of even and odd functions. So let's start. A function f of x is said to be even if f of minus x equals to f of x and odd if f of minus x equals to minus f of x for all x. For example, if f of x equals to x square and if you will replace x by minus x, so it will become minus x the whole square and again it will become x squared. So we are getting f of minus x equals to f of x. So f of x equals to x square is an even function. Now similarly, if you just think about f of x equals to x cube, and in that function if you just replace x by minus x, so it will become minus x the whole raised to 3 and again it will become minus x cube. So we are getting f of minus x equals to minus f of x. So f of x equals to x cube is an odd function. And if f of x is an even function, then we have this important result, that is integration from minus L to L f of x dx, that is equals to 2 times integration from 0 to L f of x dx. And if f of x is an odd function, then integration from minus L to L f of x dx equals to 0. Now we know that the Fourier series of a function f of x in the interval minus L to L is given by f of x equals to a0 by 2 plus sigma n is from 1 to infinite an cos n pi x by L plus sigma n is from 1 to infinite bn sin n pi x by L, where a0 equals to 1 upon L integration from minus L to L f of x dx, an equals to 1 upon L integration from minus L to L f of x cos n pi x by L dx, and bn equals to 1 upon L integration from minus L to L f of x sin n pi x by L dx. So whenever you have been given the interval minus L to L and you have to find out its Fourier series, then first of all you have to check whether the given function is an even function or odd function, or it is neither an even function nor an odd function. So based on even function or odd function, you have to find out a0, an and bn. So based on an even function or odd function, we have different cases. So case number 1, when f of x is an even function, integration from minus L to L f of x dx, that is equals to 2 times integration from 0 to L f of x dx. Now you know that a0 equals to 1 upon L integration from minus L to L f of x dx. But here we are considering that f of x is an even function. So a0 will become 2 by L integration from 0 to L f of x dx. Since the product of two even functions, the result is an even function. Now you know the formula of an, that is 1 upon L integration from minus L to L f of x cos n pi x by L dx, right? Now here we are considering f of x is an even function and cos is also an even function. So even into even, the result is an even function. So an will become 2 by L integration from 0 to L f of x cos n pi x by L dx. Now the product of an even function and odd function, that is an odd function. So you know the formula of Bn, that is 1 over L integration from minus L to L f of x sin n pi x by L dx. Here we are considering that f of x is an even function and sin is an odd function. So even function into odd function, the result is an odd function. So Bn will become 0. Now if you have to find out the Fourier series of function of x and which is an even function, then you have to find out only a0 and an, because Bn will become 0. So this was case number 1. we will see case number 2. When f of x is an odd function, integration from minus L to L f of x dx is 0, right? Now, you know the formula of A0, that is 1 upon L, integration from minus L to L f of x dx, and here we are considering that f of x is an odd function, so definitely integration from minus L to L f of x dx, that will become 0, so we have A0 equals to 0. Now, since the product of an odd function and even function, the result is an odd function. Now, you know the formula of An, that is 1 upon L, integration from minus L to L f of x cos n pi x by L dx. Here we are considering f of x is an odd function and cos is an even function. So, odd into even, the result is an odd function. So, definitely we will be having An equals to 0. Now, we will think about Bn. Since the product of two odd functions, the result is an even function. And as you know, the formula of Bn, that is 1 upon L, integration from minus L to f of x sin n pi x by L dx. Here f of x is an odd function, sin is also an odd function. So product of two odd functions, the result is an even function. So Bn, that is equals to 2 upon L, integration from 0 to L f of x sin n pi x by L dx. Now, whenever you have been given interval minus L to L and f of x is an odd function and you are interested in finding out its Fourier series, then definitely we will be having a0 equals to 0, an equals to 0, and we have to find out only bn using this formula. But if the function is neither even nor odd, then what we have to do? We have to find out all the three, that is a0, an, and bn. Now we will discuss example number 1 related with this topic. Find the Fourier series of the function f of x equals to x minus x cube in minus 1 less than x less than 1. Here f of x equals to x minus x cube and the interval is minus 1 to 1. So we have to check whether the given function is an even function or odd function. So replacing x by minus x, this is equals to minus x minus, replacing x by minus x, so it will become minus x the whole raised to 3, so it will become minus x cube, multiplying minus x cube by minus sign, so it will become plus. So we have f of minus x equals to minus x plus x cube. Now taking minus sign common, so we have minus into bracket x minus x cube, and x minus x cube, that is nothing but the given function. So we have f of minus x equals to minus f of x. So from this result we can say that f of x is an odd function. So a0 and an will be 0 and we have to find out only bn. Now comparing minus 1 comma 1 with minus L comma L, so we will get L equals to 1. Now the Fourier series of an odd function with the period 2L equals to 2 is given by f of x equals to sigma n is from 1 to infinite bn sin n by x by L cos a0 and an both are 0. Now sigma n is from 1 to infinite, bn will be as it is, replacing L by 1, so we have sin n by x. Now we will find out bn only. The formula of bn is 2 by L, integration from 0 to L, f of x sin n pi x by L dx. Now here in this expression, replacing L by 1, so we have 2 by 1 is 2, and integration from 0 to 1, and f of x, that is equals to x minus x cube sin n pi x by 1, so it is sin n pi x dx. Now we have to integrate this function, that is x minus x cube sin n pi x. So to integrate the function x minus x cube into sin n pi x dx, we will apply Bernoulli formula. So according to Bernoulli formula, we have to keep this function, that is x minus x cube, as it is. Then after we have to find out the derivative of this function. So derivative of x is 1, then after minus sign, derivative of x cube is 3x square, then after derivative of 1 is 0, then after minus 3 will be as it is, and derivative of x square is 2x, so minus 3 into 2x, that is minus 6x, and finally derivative of minus 6x, minus 6 will be as it is, and derivative of x is 1. Then after we have to integrate sine n pi x. So integration of sine n pi x is minus cos n pi x upon n pi. Now again we will integrate this function with respect to x. So integration of cos n pi x is minus sine n pi x upon n pi. But already over here we have n pi, so it will become n square pi square. Then after integration of sine n pi x is minus cos n pi x upon n pi. But here it is minus sine, so it will become positive. And already we have n square pi square over here, and if you will multiply it by n pi, so it will become n cube pi cube. Then after again integrating this term, and integration of cos n pi x is sine n pi x upon n pi, and already we have n cube pi cube over here, so it will become n is to 4 pi is to 4, and we have to keep alternate sign, positive, then after negative, positive, and finally negative, and the limit is from 0 to 1. Now first of all we will put down upper limit, that is 1. If we will put the value of x equals to 1 over here, so 1 minus 1, it is 0. And for the second term, if we will put the value of x equals to 1 over here, so it is sine n pi, and the value of sine n pi is 0. Now for this term cos n pi, and the value of cos n pi is minus 1 is to n. So we will be having this term for x equals to 1. And then after, for this term, if we replace x by 1, so it is sine n pi, and the value of sine n pi is 0. So for x equals to 1, we will be having one term only, that is this one. Now for x equals to 0, this term will become 0 because 0 minus 0 gives 0. Then after sine 0 is 0, so again this will be eliminated. Then after if you replace x by 0 over here, so again it will be eliminated. If you multiply 0 by any result, the result is 0. And again sine 0 is 0. So we have only one term for x equals to 1. So 2 will be as it is. Then after minus 6 into 1, result is minus 6, replacing x by 1, so it is cos n pi and divided by n cube pi cube. And we have to write down this reason, that is sin n pi equals to sin 0 equals 0. Now we will simplify this result, so 2 into minus 6, that is minus 12. And cos n pi is minus 1 is to n divided by n cube pi cube. And the value of cos n pi is minus 1 is to n. Now, f of x, that is equals to sigma n is from 1 to infinite Bn sin n pi x. Now we will replace Bn by this function. So it is sigma n is from 1 to infinite minus 12 minus 1 is to n upon n cube pi cube into sin n pi x. And f of x is x minus x cube, that is equals to, writing constant value outside, so it is minus 12 by pi cube. Sigma n is from 1 to infinite minus 1 is to n upon n cube into sin n pi x. So in this lecture we have discussed basic concepts of even and odd functions and how to find out the Fourier series of an even and odd functions, and one example in the interval minus L to L, which was an odd function, and we have seen how to find out its Fourier series. Thank you for watching this video. I will see you in the next lecture.